Mathematics is the language in which the universe is written. It is all around us, in the spiral of a galaxy and the branching of a tree. It is a tool. This tool helps us understand our world. It helps us count our possessions. It helps us measure distances. It helps us solve complex problems. You are using mathematics when you follow a recipe to bake a cake. The measurements for flour and sugar are precise quantities. You use math when you calculate your travel time to work. You use it when you simply check the clock on the wall. Understanding the fundamentals of this language does not require genius. It simply requires curiosity and a willingness to see the patterns that govern our reality. This journey is not about becoming a professional mathematician overnight. It is about demystifying a subject that often seems intimidating. We will start with the most basic of ideas. We will build upon them, step by step, just as our ancestors did over thousands of years. Think of math as a story. It is the story of how we learned to quantify our world, to predict its movements, and to build the civilization we live in today. From the simple act of counting sheep to the complex calculations that send probes to distant planets, the underlying principles are connected. The goal is to give you the confidence to use this powerful tool in your own daily life, making it a little clearer and a lot more manageable. Consider a simple act: buying groceries. You have a list of items. Each item has a price. You place them in your cart. At checkout, prices are added. A sales tax, a percentage might be applied. You pay and receive change, a symphony of operations. Our story begins with the most fundamental concept: the number. Numbers are symbols we use to represent quantity. They are the alphabet of mathematics. We start with counting: 1, 2, 3. This simple sequence answers, how many? We can count apples, or days in a week. We write these quantities using digits, 0 through 9. These 10 symbols, in combinations, represent any number imaginable, from people in a room to stars in our galaxy. From these digits we build larger numbers. The clever idea is place value. A digit's position determines its value. Consider 273. The 3 is ones, just 3. The 7 is tens, 70. The 2 is hundreds, 200. This system expresses vast quantities with only 10 digits, an efficient, elegant code for the world. Do not forget the hero, 0. As nothingness and placeholder, it was a profound leap. In 508, 0 holds the tens place. No tens. Without it, 58. A different value. 0 divides positive and negative and is the starting point on a number line. Its invention revolutionized calculation, the bedrock for all further mathematics. Once we can count, we combine or separate groups. Addition combines quantities. How many in total? 3 books plus 4 makes 7. Growth, accumulation, bringing things together. Subtraction takes away. How many are left? 7 minus 2 equals 5. Reduction, comparison. Pay 12. With 20, 8 back. Multiplication is a shortcut for repeated addition. 5 packs, 6 each. 5 times 6 is 30. We scale quantities, costs of multiples, area of a room, seats in identical rows. Division splits into equal parts. 20 cookies shared among 4, each gets 5. Sharing, distribution, rates. Miles per gallon equals miles divided by gallons. These 4 operations are the workhorses of everyday math, constantly at play in our lives. Each concept is a stepping stone to the next. Our world is not always whole. We often deal with parts, fractions. A fraction is a piece of a larger unit. Eat 1 slice, you ate 1/8, written 1/8. Denominator shows total parts, numerator shows parts taken. Fractions are everywhere: 1/2 cup, 3/4 of an inch. Decimals are fractions in place value form. The point separates whole from fractional parts. 3.5 is 3 wholes and 5/10, same as 3.5. Money is decimal, 12 and 75/100. Percent means per 100. 50% is 50 out of 100. 50, 100, shearer 1, 2, 0, 50. 25% off means you save 25 per 100. 0.75 cups is 3/4 cup measures. Fractions, decimals, percentages, different ways to say the same thing. Translate between them. It is powerful. Mathematics is not just numbers, it is shapes and space, the realm of geometry. Look around. Rectangles, cylinders, spheres. Geometry studies forms and their properties. From points and lines we construct the architecture of our universe. Nature's hexagons, city rectangles. Perimeter is the total distance around a 2D shape. For a rectangular garden, add all 4 sides, useful for fencing. For a circle, that boundary is the circumference. Area measures how much surface is inside. For rectangles, area equals length times width, useful for paint or carpet. We live in 3D, volume measures, space an object occupies. For a box, length times width times height, the box's capacity. Volume matters in shipping, cooking, chemistry. A liter is a specific volume. Geometry, perimeter, area, volume, tools to measure and interact with physical space. As we grow comfortable with numbers, we take a powerful step. We use symbols, letters like X or Y, to represent unknowns. This is algebra. Algebra is detective work. Find the missing piece. An equation states two things are equal. In x plus 5 equals 12, we isolate x by doing the same operation to both sides. Subtract 5 on both sides. X plus 5, 5, r, 12, 5. We get x bar 7. Need 50, have 35. How much more? Write 35 plus x bar 50. Subtract, you need 15 more. Functions model relationships. Cost equals 2 times miles plus 3. For 10 miles, 2 times 10 plus 3, 23. Algebra and functions let us model, predict, and understand how variables interact. A systematic language for setting up and solving problems, especially as they grow complex. The world is filled with data. Statistics helps us collect, organize, analyze, and interpret it. The average or mean add values and divide by the count. 80, 90, 100. Mean is 90. Median is the middle value in order. Mode appears most often. Together with mean, they are measures of central tendency. Probability measures likelihood on a scale from 0, impossible, to 1, certain. A fair coin, 2 outcomes, heads or tails. Probability of heads is 1-2 margin 0.5 0 50%. It does not predict a single flip but what happens over many. We use probability daily. Forecasts, medical risks, decisions under uncertainty. Statistics and probability help us find patterns, summarize information, and quantify chance. Knowing concepts is one thing. Applying them is another. Problem solving is an art with strategy. Step 1. Read and understand. Do not rush. Read it twice. Identify what you must find. Clarify your goal. Step 2. List the given facts and numbers. Separate what you know from what you need. Example. Speed 60 miles per hour. Time 3.5 hours. Unknown distance. Step 3. Choose a strategy. Which relationship connects them? Distance equals speed times time. Execute, then check. 60 times 3.5 is 210 miles. Units and reasonableness make sense. A simple, 5-box flow. Understand, identify, plan, execute, check. If a result seems off, your check will catch mistakes. We have journeyed from counting to structured problem solving, a logical language describing the universe, numbers and place value, operations, fractions and decimals, geometry. We peeked into algebra, statistics and probability. Mastery comes from practice, not genius. 10 to 15 focused minutes. Solve a few problems, check a receipt, compute a discount, estimate a tip. Each small act strengthens pathways and confidence. Mathematical thinking is logic, pattern recognition, and breaking big problems into manageable parts. Be patient. Mistakes are opportunities. Start with basics and build. From atoms to galaxies, the universe is patterned. With mathematics, you hold a key. Use it, practice, and keep exploring.